Hello everyone, I am Sunil Das and my roll number is 25951A05N8. Today I will be presenting on the topic high tech, high sec security concerns and graph databases. This is the topic of my subject, graph data structures at Institute of Aeronautical Engineering, CSE department. I want to talk about why there are a massive security headache if not handled correctly. The rise of graph databases, a new frontier for data. So, why are we seeing a shift away from traditional databases? Well, graph databases are built for complexity, while old school relational databases struggle with the performance when the data gets too messy. Graphs excel at managing highly interconnected dynamic information. They handle many to many relationships naturally, no more slow, expensive joints. This is exactly why things like recommendation engineer engines and fraud detection systems use them to find hidden patterns. Complex data mastery. Graph databases excel at managing a highly interconnected to dynamic data, where relational databases struggle with performance and complexity, relationship power, uh, and AI analytics. They naturally represent many relationships without costly joins, making them ideal for social network and knowledge graphs. AI and analytics, fraud detection, recommendation engine, and AI system leverage graph traversal to uncover hidden pattern and sites. Unique security challenges of graph data. However, at that some interconnectedness is a double-edged sword. We have in this we have mainly three challenges here. First is cascading breaches. Because everything is linked, one small breach can spread like wildfire across uh, entire network. Second one is query pattern exposure. Sometimes the way a user searches can actually leak sensitive info about personal or organizational connections. Lastly, because dynamic access control graphs are always evolving, which make traditional static security models almost impossible to apply. Unique security challenges of graph data. Cascading breaches. The interconnected nature means a single breach can propagate rapidly across entire network, exposing vast amount of related data. Query pattern exposure. Graph traversal can reveal sensitive relationship patterns that weren't intended to be exposed, exposing organizational or personal connections. Dynamic access control, unlike staticable structure, dynamic graph structure with evolving nodes, relation complicate traditional access control. Vulnerability landscape, Neo4j and beyond. Neo4j is basically like a software to for databases. When you look at the landscape, especially with the tools like a Neo4j, Neo4j is a tool. We see critical gaps. We are dealing with things like a Neo4 injection, which is which is um, uh, which is essentially the graph version of SQL injection. We also see a lot of open query endpoints like GraphQL or Gremlin API just sitting there without proper authentication. If an attacker gets in, a simple traversal query could let them dump an essential data set, salaries, static plans, you name it. Anyway, Critical security graphs. Graph databases pack unique attack surfaces that differ from traditional SQL-based systems. Neo4j, exploiting the vulnerability specific to Neo4j and similar graph engines. Open query endpoints, GraphQL, Cipher over HTTP, and Gremlin APIs exposed without proper authentication. Manage data extraction. Attack vector and exploits. Attack vectors and exploits. Let's talk about how these attackers actually happen. Now, you have probably heard of the little Bobby tables, SQL injection joke. Well, that has evolved. Attackers now use query language injection to exploit Cipher and Gremlin. They craft malicious queries to bypass security and grab data they aren't supposed to be. This is especially dangerous in cloud environment where misconfigured permissions are unfortunately common. Attackers vectors are expert. Query language injection. Little Bobby tables has evolved SQL injection technique adapted to exploit Cipher, GraphQL, and Gremlin query languages. Cipher manipulation. Attackers craft malicious security ciphers queries to bypass security controls, traverse unauthorized relationships, and extract sensitive data. Cloud environment risk. Graph databases are deployed in cloud environment with additional threats from misconfigured permissions and exposed API endpoints. This is a single node problem. This visual really hammers home the risk. If just one node in our graph is compromised, it's game over. An attacker doesn't need to break into every room. They just need to get into the hallway from one single node. They can travel relation to attack, access connected data across the entire network. One vulnerability truly can expose everything. When one node is compromised in a graph databases, attackers can traverse relationships to access connected data across the entire network. A single vulnerability node exposes everything. Mean a single mistake problem can expose every sensitive data. Next is proactive security measures. So how do we fix this? We need a security first. We need a security first design. We can't just build security on at the end. It has to be part of the initial architecture. We need robust identity management, granular control over who can traverse which relationships, and of course the basic encryption at rest and in transit using TLS is non-negotiable. Security first design. Incorporate cybersecurity, identity management, encryption standards. Security first design. Incorporate cybersecurity measures during initial system architecture design. Retrofitting security later proves costly and less effective. Identity management. Implement robust authentication and granular authorization mechanism to control over who can traverse which relationships. Next is granular access control. To get even more specific, we should enforce security at the databases engine level. This prevents unauthorized travel before a query even executes. We also use role-based restriction based on the job function and schema-based security, which uses the graph's own structure to automatically enforce access rules on specific nodes or relationships. Database level security enforce a rigorous security rules at database engine level, preventing unauthorized traversal before query execute. Role-based restrictions. Schema-based security. Mitigation and best practices. Looking at industry leaders, the Veronese approach emphasizes securing query endpoints and monitoring AI systems from day one. Similarly, the Neo4j security stack offers built-in tools for encrypted communication and schema-based enforcement. But the most important thing is continuous monitoring. We have to be auditing for suspicious query patterns and analyze query behavior 24 by 7. The future of graph security. As we look ahead, security has to be foundational, not an overthought. As the databases become more integral to AI, the stacks so only get higher. Organizations have to stay ahead of the curve through constant education and proactive design. The bottom line is, if you want the analytic power of a graph, we need the sophisticated security to match. Thank you. In this, we have discussed about the high tech security about the databases. Means how can we protect and what are the problems? Thank you.